Alright, in this session I'm going to talk about blueprint reading, and most likely the majority of you read blueprints every day. And what I mainly want to talk about is I want you to start looking at blueprints from a CNC programmer standpoint. Okay, so when a blueprint is handed to you, what information do you start looking for as a programmer? So the first thing I would look at obviously is the part shape and determine whether it's a mill or a lathe job. Well, it's very obvious here that this would be a mill job. And then I look at the size. It's 18 inches long, and then over here I see 7 inches wide and 1 inch thick. So that helps me kind of visualize the size of it. And in this case I actually have somewhat of a 3D representation helping me identify the thickness and some of the features, whether they are on the far side, near side, bottom side, or if they are through or not. Okay, then I want to know what type of material I'm going to be making that out of, and in this case it's over here in the notes. So it says material CRS, so that's cold roll steel. And it could either be in the notes or somewhere in the title block. You know, every company does it different. When you get used to one customer, then you see this information in the same place. But if you're working for multiple customers, then you probably have to dig around a little bit to get that information. Alright, so the next thing I look for is obviously the features on the part to make sure there's nothing critical there, especially the tolerancing scheme. And if you look in the table or the title block, you can see the tolerancing scheme. Now this is probably a default tolerancing scheme, a template probably that they use for every drawing that they make. So if there are fractions on the print, then they have a plus or minus 1/32 tolerance. Any two place decimals right here will be plus or minus 10 thousandths, and any three place decimals plus or minus 5. So when I zoom out and I take a look at the dimensions, then the majority that I look at are a three place decimal, so everything is plus or minus 5. So the only place where I have some extra tolerance right here is on this 18-inch overall length. Okay, so the rest is all plus or minus 5, and a CNC machine probably doesn't have any issues holding a plus or minus 5 dimension. Then we look at these notes next to these holes to make sure we understand what they mean. There's a 410 diameter through and a 600 counterbore 400 deep. Now notice that there's a hidden line, so most likely, as you can see, in the 3D representation of those counterbores are going to be put in from the bottom side. Okay, then it's hard to see from this view that these two holes right here and here that are 875 in diameter, if they are through or not. And why is there a double line? So if I look in the front view, then I can see that that's actually a blind hole with a 1-inch diameter at the top and an 875 at the bottom. And it looks like I need to be 570 deep for the 1-inch diameter and then 130 deep on that 875. Okay, so that's fairly simple. Understanding how the views are projected is probably a very basic understanding. Right here I'm looking at the top view or the main view. Then if a view is rotated below it, then that would be considered the front view, and anything to the right would be considered a right view. Now it's obvious that this is just an isometric view right here in the upper right hand corner, but if there was a view above the part, then it would be considered a back view, and if I have a view on the left side of a part, then it will be the left view. So to clarify that, let me pull up the solid model and show you how these views are rotated to kind of help you visualize that. So here I'm looking at the main view like we're seeing it in the top left corner of the drawing, and that's where all the dimensions come from. Now this is the solid view. If I turn it to wireframe, then you can see some of these other features that are hidden, But what I want to clarify is the way the part is rotated on the print. So the view below the part will be rotated like so. Okay? So that would be the view that you see below the part. So this is considered the front view. Alright? So if the view was projected above the part, then I'd be looking at this view. Okay? Then if I was looking at this side of the part, obviously that would be the right side. Then that would be the right view of that main view projection. Okay? And if I have a projection on the left side, then I will be looking at the part like this. Now, once the part is projected, let's say to the front, let me go ahead and straighten that out. Now, if I look at the right side of the front view, I'd still look at it like this for the right and this for the left. Okay, so here we're back to top. Alright, so I hope that makes sense. So what I'd like you to do is at work, when you're making parts, grab one of those parts, take a look at the print, and study how these projections are. Top view, front, back, right, left, and if there's any other section views. And if you can see the 3D on the print, just like you see the 3D representation of your part. Alright, so let's go back to the print. Alright, so let's take a quick look at the title block right here and see what information we find there. And it's all pretty straightforward. The company name is going to be your customer name. Then it will be a part description, which is usually the name of the part. The part number or drawing number will be the number that the engineers have assigned to it. Then the revision A, if you ran this, let's say 6 months ago and the revision is still A, then that means no changes were made. If that went from an A to a B, then you better be looking at what dimensions may have changed. Okay? Then the date that the drawing was created, the scale of the drawing, drawn by and approved by, it's all self-explanatory. And then sheet 1 of 1, if it said sheet 1 of 2, then I would be looking for a page 2 to see if there's any additional information on this part. So once I read all of that, I basically think about, okay, how would I process this thing? So the first operation I think would be fairly obvious. We're going to do all these features right here in this view. The next thing you want to determine is where do you put your origin? Well, so I look at the way the part is dimensioned, and it looks like everything is coming from the left side here, and then also these holes are coming from the top side of the part. So the intersection right here I would definitely call x0, y0, because if I am drilling a hole, then I will actually see an x value of 380 right here, and then minus 501 for this first hole. Okay, so that allows you to verify the location of that hole based on the dimensions that you see on the print. It makes it very simple to troubleshoot or to verify that your locations are correct. Alright, then what other operations would I have to do? It looks like on the second side or the bottom side we have some counterbores. So these through holes right here on the ends, so there'll be a total of 8 holes. We would obviously be drilling from side 1, and then we would have to flip it over. Then once you flip it over, I would still make sure I use this corner, which will now be on the opposite side. If I flip it 180 degrees, I would still call that x0, y0. So when I come over 380 and minus 1 inch 501, I will be lined up with that hole again. So then the third operation would be putting in these holes on the end. They are 1/4 inch threaded holes, and it looks like they are in the middle, 500, typical 4 places. I would still use this end x0, and then probably center line of the plate y0, or just the far side y0, and then your coordinate in y should read y minus 0.5. So if the origin was in the center, then obviously the y value would be 0. So you have an option there that doesn't really matter. So those are some of the basic things I look for. And as a CNC programmer, you'll probably look at a lot of prints, especially when you're quoting them. You just kind of have to scan the prints for that basic information we just went over and just in your head process how many different setups it would take. In this case, it would take 3 setups, top side, bottom side, and the holes on the side. So that gives you an idea of how much time you would have to spend programming, setup, and then actually machining those features. So when you're in the shop, go ahead and study the prints and look for those features and look for the information that we just went over, and in your mind process that part, see how many processes it would take to machine that at a minimum, and where you would place your origin based on the dimensioning scheme.